The question we are solving now belongs to test series 4. It is of signals and systems subject. In specific, it belongs to basics of signals. Please note that this is a linked answer question. As per the question, there is a signal x of n as shown in the figure. The signal x of n takes a value of 2 at n is equal to 0, and it takes the values of 1 at n is equal to minus 1 and plus 1, and it takes a value of half at n is equal to minus 2 and plus 2. It is given that there is a signal y of n which is derived from x of n as y of n is equal to x of n by 2 minus 1 when n is even and 0 when n is odd. We need to pick the correct option that represents the plot of y of n. And from the given data, we see that y of n can be obtained from x of n by delaying x of n by 1 unit. So because of which we get x of n minus 1. Then upscale x of n, or rather say upscale x of n minus 1, which leads to x of n by 2 minus 1. So based on this data, first let us delay x of n by 1 unit to get x of n as shown. So due to the delay of x of n by 1 unit, we see that we get the samples as shown. Now this is due as a resultant of delaying x of n by 1. Now we need to upscale or upsample x of n along n axis by a factor of 2, because of which the sample at 0 remains as 1 and the sample at instant moves to 2 because of the upscaling. Similarly, we find the samples at 4 and 6 and minus 2. And we see that the sample at 2 has a value of 2 and the sample at 0 and 4 has a value of 1 and the sample at minus 2 and 6 have a value of half, and every other sample has a value of 0 as a resultant of upsampling. So this is x of n by 2 minus 1, assuming that when n is the odd, the signal will take a values of 0. So from this we see that y of n can be obtained from x of n by delaying x of n by 1 unit and the upsampling the resultant signal by 2 along the n axis to get y of n. So from this we see that whatever plot we get corresponds to what we got corresponds to y of n, and the correct option representing the plot of y of n is A.